All right, now we're looking at 5.3. We're going to look more at graphs of polynomial functions. We already have looked at the first three of these graphing tools, and this time we're going to focus on multiplicity. So let's use our graphing tools to try to graph this polynomial function that's given to us in already factored form. So we'll start off with looking at x-intercepts. So to do that, we set the function equal to 0. And we're going to solve for x. So to do this, I'm going to leave this x plus 3 squared just as it is, but let's factor this x squared minus 4. Now, I don't really have to do this, but for purposes of the example, we're going to factor that. It's the difference of two squares. We have x and x, and then 2 and 2, and we have a plus in one of them and a minus in the other. So now we set all of our factors equal to 0. And here we're going to take the square root of both sides. So if we do that, we get just x plus 3 x plus 3 equals 0. So x equals negative 3. And here we get x equals negative 2, and here we get x equals 2. All right, so we get 3 x-intercepts. All right, let's look at the y-intercept. Here's where we evaluate the function at 0. So plugging a 0 in, we're going to get 0 plus 3 squared, 0 squared minus 4. So that's going to give us a 3 squared times a negative 4, or a 9 times a negative 4, which is negative 36. Okay, so that's our y-intercept. Y equals negative 36. Now, we want end behavior. All right, we basically want to figure out what's happening on the far left and the far right. Well, what we care about is the degree and the leading coefficient. So to get that, we need to figure out the lead term, and we're going to multiply together all the x terms. So if we look at what that is, it's x times x times x squared. All right, because x plus 3 is squared, so that means it's going to show up 2 times, and we get a lead term of x to the 4th. So the degree is 4, the leading coefficient is 1, so we have even degree, positive leading coefficient, so that tells us that it's going to go up on the left and up on the right. Okay, now we have the tools that we need to sketch a graph. Okay, let's label this as negative 36, and we'll just put our y-intercept right there. And then plot our x-intercepts at negative 3, negative 2, and positive 2. And then we're going up on the left and up on the right. So when we go to sketch the graph, we're going to start above the x-axis, go through that first x-intercept. We're going to cross we have to make a turn to go through the next x-intercept. And now if we look to see what the next thing is that we need to do, well, we need to somehow get down here to this y-intercept. Well, you notice there is no x-intercept here in between negative 2 and 0. So we can't just make our graph go through there because there's no x-intercept. So here is where multiplicity is going to come into play, because we have a big mystery right here with this graph. Okay, so here's what multiplicity is. We have a factor like x minus r, and it has an exponent of k. It's going to give us a 0 of x equal to r. So for our example, we had a factor of x plus 3 squared. And that gives us a 0 of x equal to negative 3. And if that 0 that we get from the factor is real, then it's an x-intercept. And so our x-intercept is negative 3, 0. Okay, so here's where the multiplicity part is. A 0r has multiplicity of k. So notice that that multiplicity is the exponent that goes on the factor. Okay, so the k for this example, is 2, because the exponent on the factor was 2. Okay, now what does that have to do with graphing? Well, here we're going to find out. If the x-intercept of the 0 is real, and then k is odd, the graph is going to cross the x-axis at that x-intercept. If it's even, if k is even, the graph is going to touch, or it touches the x-axis at that x-intercept, and there is a turning point. Okay, now let's use that information to finish the graph that we started. So if we look at our factored form of our polynomial, we had x plus 3 squared, x plus 2, x minus 2. And from that, we got x equals negative 3, x equals negative 2, and x equals 2. They're all real, so they are all x-intercepts. But now we have to think about multiplicity. So k for x equal to negative 3, is 2, and it's even. So the graph is going to touch at that x-intercept. For x equal to negative 2, our multiplicity is just 1, right? There's like an exponent of 1 there. That's odd, and so we will cross at that x-intercept. And for x equal to 2, we also have multiplicity of 1. It's odd, and we will cross the x-axis. Now let's try again at graphing. So we can start above the x-axis, and we get to this first x-intercept. This had a multiplicity of 2. It's even, so we're going to touch and have a turning point. And now we want to get to our x-intercept at negative 2, so we make a turn. That had a multiplicity of, that was odd, so we're going to go ahead and cross. Now we're down here where we can get to our y-intercept. We make a turn, we go through our y-intercept, we go up, cross the x-axis at our next x-intercept because it had multiplicity of 1, that was odd. And now we end up with exactly what we needed. We're going up on the left and the right. We've crossed the x-intercepts, or touched the x-intercept where we need to, and we crossed our y-intercept. So now let's practice finding zeros and their multiplicity. All right, so remember, zeros are solutions to when f of x equals 0. And if they are real, they are x-intercepts. Okay, so this is kind of just another name for x-intercepts, but it includes those ones where we would get non-real solutions. So let's go ahead and set our function equal to 0. And find the zeros and identify their multiplicity. So we have 3 factors that we can set equal to 0. X squared equals 0. X plus 5 equals 0. X squared minus 9 equals 0. So here we get x equals 0. All right, that is a 0. And now we want to think about what its multiplicity is. Well, that goes along with the exponent that that 0 comes from. So 0, the 0 of 0 has multiplicity of 2. All right. For x plus 5, our 0 is negative 5. And the factor that it comes from, it has an exponent of 2. So its multiplicity is 2. All right, let's look at x squared minus 9. Now, it can be helpful to just go ahead and factor that, because then we can be really clear about what multiplicity is. Okay, we've got difference of 2 squares. So we have x and 3 in both of those factors, and then a plus and a minus. So we end up with x equals negative 3, x equals 3. So if we look for the multiplicity, all right, it is a 1 in both of those. So we get multiplicity of 1 for x equal to negative 3, x equal to positive 3. All right, here's another example. Let's find the zeros and the multiplicity. So we start off by setting that function equal to 0 and solving for x. Now, it is not factored for us, so we're going to need to do some factoring. So let's bring out a 4 and an x squared. That's the greatest common factor. And then we're left with x minus 4. Okay, so we can set our factors equal to 0 and solve. We're going to get x equals 0 and x equals 4. And now let's look at multiplicity. So for x equals 0, that comes from a factor that has exponent of 2, so it's multiplicity of 2. And x equal to 4 comes from a factor with multiplicity of 1. All right, it's not there, so that means it's 1, so it has multiplicity of 1. Here's another one where we are going to need to do some factoring, but our goal, remember, is to find zeros in multiplicity. So setting x to the 6th plus 2x to the 4th minus 8x squared equal to 0. First thing is we want to look for greatest common factor. Well, it looks like there's an x squared in each of those terms, so we'll bring an x squared out. We're left with x to the 4th plus 2x squared minus 8. Okay, now here we've got, it's not a quadratic, but it's not something that has any more greatest common factors, and it has an x to the 4th. So we haven't done a lot of factoring for those. But I'm going to rewrite this so that it kind of looks like something that follows a quadratic pattern. So if I change this x to the 4th to be x squared, and that whole thing is squared, right? If we go backwards and multiply 2 by 2, we get 4. And then plus 2 times, and then I'm going to put that x squared in red. And then we have the minus 8. So that kind of follows a quadratic form. We could even like make a replacement and say, let's let u equals x squared. And then rewrite this. We get x squared out in front times, this now becomes u squared plus 2u minus 8 equals 0. Okay, that is a quadratic. And we know how to factor that, and we solve for x. So we have the x squared out in front. We don't want to forget that. And then we can write two linear factors with the u and the u, and think about what multiplies to negative 8 and adds to a positive 2, and that's going to be plus 4 minus 2. And now we have x squared equals 0. U plus 4 equals 0, u minus 2 equals 0. Now, the thing is, we do not really want u, we want x. So we're going to now make the replacement back and say we have x squared plus 4 equals 0. x squared minus 2 equals 0. Okay, so a little bit more to do then. We've got x squared equals negative 4. If we try to take the square root, all right, we got a plus or minus out in front. Well, we end up with x being not real, right? Because we have a negative under the square root. So this is not a real 0. So it's not going to give us an x-intercept. Okay. Then we look at the x squared minus 2. We add 2 to both sides and then take the square root. And we're going to get x equals plus or minus square root of 2. Okay, those are irrational, but they are real. Now, we also want to look at multiplicity. So the exponent on the factor that x equal to 0 came from was 2, so that has multiplicity of 2. We don't really talk about multiplicity for not real, so you can just kind of ignore that. And for x equal to plus or minus 2, if we look at the factor that it comes from, so if we kind of replace that u minus 2 with that x squared minus 2, all right, that's the factor that gives us x equals plus and negative square root 2. Now, we don't usually ever do this, but if we were to factor that, it would be like x plus square root 2, x minus square root 2. All right, so I do that just to show you that, well, those both have an exponent of 1. So both x equal to square root 2 and negative square root 2 have multiplicity of just 1. Okay, one last example for this video. This time around, we are just going to go through the whole process of sketching the graph. And we now know that we want to look at multiplicity when we look at our x-intercepts. So start off with those x-intercepts. We are going to set the function equal to 0. I'm going to kind of skip a step and just set the factors equal to 0 and solve those for x. So we get x equals 0, we get x equals negative 5, and we get x equals 3, x equals negative 3. Now we want to look at multiplicity. So for x equal to 0, we have multiplicity of 2. It's even, so when we go to graph, we want to make sure we just touch the x-axis and not cross it. For x equal to 5, that comes from this factor, and it has an exponent of 2, so its multiplicity is 2, also even. So we're also going to touch the x-axis at x equal to negative 5. And at x equal to 3, so I kind of skipped over this, but just remember this is going to factor as x plus 3, x minus 3. All right, so those both have exponent of 1. So both of these have multiplicity of 1. They're both odd. And so we're going to cross at both of those x-intercepts. Okay, now let's look at for the y-intercept. So here's where we are going to evaluate at 0. So we plug in a 0 for all the x's. And we end up with 0 times 5 squared times negative 9. Well, since we have this 0 here, the whole thing is 0. So our y-intercept is y equal to 0. End behavior. We need the lead term. We're going to multiply the terms with x's, and we want to the x plus 5, because that's squared, this x is going to show up twice. We got to kind of double dip on that one. So what we have is x squared times x. All right, that's for the x plus 5 2 times, and then finally that x squared at the end. So we've got, if we count up those exponents, we have exponent of 6. So our lead term is x to the 6. So that tells us that the degree is 6, and it's even, which is what we need to know, and the leading coefficient is equal to 1, and it is positive. That tells us that the graph is going to go up on the left and up on the right. Okay, let's start by plotting our intercepts. Our x and y intercept are 0. We've got an x-intercept at -5, and x-intercepts at plus and minus 3. We have end behavior going up on both the left and the right. So now as we sketch the graph, we want to remember where we're going to touch, where we're going to cross. So we're going to touch and have turning points at 0 and -5. Starting above the x-axis, we come to that -5, we touch, make a turning point, and then we're going to have another turning point to go through -3. Here we're going to cross because that one had an odd multiplicity. And then we need a turning point to go through x-intercept at 0, but that one has an even multiplicity, so we're going to turn, and then we need another turn to go through x-intercept at 3. No more x-intercepts. We end up above the x-axis. We're going up on the right, which we needed to. And there's our graph.